Welcome to Math 1324. This is section 5.1. We're going to be looking at graphing inequalities in the plane where we have x's and y's. So we'll do this in two parts. One, I'll go through the PDF file of how to do the homework, and then we'll look actually in my math lab and see how to do the graphing. Alright, so the very first question is fairly straightforward. Is this point 2, 6 on the line? Well, without graphing, all we have to do is plug in my point. So x is 2, y equals 6, and let's see if it makes a true statement or not. Alright, so y is 6. X is 2, 6 times 2 is 12, 12 minus 6. Alright, and so I get 6 is 6. So that would be true. What if I picked another point, like 1, 7? Would that be true? Let's see, y is 7. 6 times 1 is 6. 6 minus 6 is 0. And so I would get 7, 0. 7 equals 0, and that's not true. So if it makes something true, the point is on the line. And if it makes something that's not true, the point is not on the line. In question 2, we have a point, and we want to know if the point satisfies this inequality that has both y and x in it. So let's see, 3, 10, x is 3, y is 10. So let's see, 4 times 10 minus 5 times the x, which is 3. We want to know, is that greater than or equal to 5? Let's see, 40 minus 15, that's a 25. Is 25 greater than or equal to 5? Yes, that is true. Alright, question 3. Question 3, we'd like to actually graph this inequality. So, there are a couple of things that's going on here. First, I need to graph the line itself. Without the inequality, just the line y equals x minus 3. Well, I know that the y-intercept is here at minus 3. What about the x-intercept? Well, I could find that easily, setting y to 0. I get x is 3. So my line is crossing at 3, 0. So here's what my line looks like. Now, the inequality, see how it has the line under it? That means that when I graph this line, it's going to be a solid line. Whereas if we had something that looked like this inequality, so if it had no line, then my line would be dotted. Next, I need to figure out which side of the line do I shade. And I do that by picking a test point. And the test point is any point that's on one side or the other. Now, most of the time, a great test point is the origin, 0, 0. So I try it out, 0, 0. Is it true 0 is greater than or equal to 0 minus 3? See, all I'm doing is plugging in the test point back into the original problem. Is 0 greater than or equal to minus 3? Yes, that's true, so I'm going to shade this entire side. So every point on that side would satisfy the inequality. If it would have failed, then I would have shaded the other side. All right, let's jump over to my math lab and see what this looks like. So here's the homework problem. in my math lab, question 3, we have, hopefully you can see this, y less than or equal to x plus 5. So I see the graph. What do I do with it? Nothing to click here. So I click over here, click to enlarge the graph. Notice I get a graph and a bunch of tools. All right, pointing tool. This is a line. This is if I needed to graph an absolute value, a parabola, and a parabola on its side, or a circle. All right, so clearly we're going to use the line tool. Now remember, we said the line was solid or dotted. See, there's 2 of those. And this little symbol is where I'm going to fill in which side works. So let's see, our line is solid, so yes, that's selected. I need to select my line tool. So you see, when I come over here, it's looking for a first point. Because I had y equals x plus 5, that's my first point. Now I need another point. Well, I can pick anything that I like. So if I let x be 1, then I'd have 1 plus 5, which is 6, and there's my other one. So you see, there's my line. All right, let's see if it likes that. So it graphed it. So there's my line. Now I need to figure out which side works. What if I picked 0, 0? Is it true 0 is less than or equal to 0 plus 5? Yes, that is true. So I get my little fill tool, and I'm going to fill that side. Now, if you didn't like something, you can say clear or delete and start over. And so now when I save it, it puts it into my problem, and we can check the answer. So let's check and see. And it likes it. Okay, so let's go back to our problems now. All right, in question 4, we want to graph the inequality x greater than or equal to 4. Well, let's see. X equals 4 is a vertical line, right? That just has x equals, so it's vertical. Because of the inequality, it's a solid line. Okay, so there it is. Now, if we had y equals a number by itself, then it's perfectly flat. So again, x equals a number is vertical. All right, so I'm going to pick my test point. 0, 0 is not on the line. So let's see, is 0 greater than or equal to 4? No. So I'm not going to shade this side. I shade the other side. All right, what about question 5 here? Let's see. First off, it's going to be a solid line. I need to graph the line itself. Now, the easiest is to graph the x and y intercepts if possible. So let's see, if I set x to 0, I get 7y is 28, or y is 4. See, that gives me 0, 4. If I set y to 0, I get 4x is 28, and I get x is 7. So there's my 7, 0. Use my line tool to make the solid line. And now we pick our test point. Let's see, 0 plus 0, is that less than or equal to 28? Yes. So therefore, shade that entire side. All right, so let's see question 6. First off, based on the inequality, it's going to be a solid line. Let's see, it's not very convenient, but if I picked x or y to be 0, I would get the origin. So it is a downward going line. Why is it downward? Well, if I solve for y, I get a minus 7/2 x. Alright, so the origin is 1. What's another point? Well, there's no real easy way to do this, but I'm noticing if I let x be 2, 2 times 2, those would cancel, and y would be minus 7. Another way to look at it is over 2, down 7, based on rise and run for our slope. So I can now make my line. Now, what about my test point? I usually pick the origin. Well, I can't because that lives on the line. So I'm going to pick this one, 2, 0. I know it's on one side. Let's see. 7 times 2 is 14. Is that greater than or equal to 0? Yes. So therefore, I would shade that side. Let's see. These are fun. Question 7. All right, so I want to graph this inequality. First thing I notice is it is an inequality without an equals. So it's going to be dotted. Okay, let's see. And what else? So I'm going to graph my line. It's dotted. Set x and y to 0. So if x is 0, y is 2. If y is 0, x is 4. So here are my two dots. It is a dotted line, sorry. I pick my test point to see if it works or not. 0 is less than 8, so yes, it would be shading this side. And so then it says use the graphing tool to graph the set of points that do not satisfy it. Do not. That means it's the other side plus all the items that lived on the line. Right? So before it was everything under the line. So if I'm looking at what does not, it would be the line and everything above it. All right, question 8. We have 1, 2, 3 things to graph. First off, what about this? X equals 0. X equals 0 is the vertical line, and you must graph that. Y equals 0. It's this horizontal line. And then now we would graph the line itself. And so graphing the line itself, I would pick x and y to be 0. And so I graph my line. It is a dotted line because there's no line. So notice that gives me all kinds of regions that are possible that might work. So I'm going to pick a test point, and I'm picking 50, 50 because the numbers are pretty big. And if I pick that point, I find out that the region that works is everything in here. Now, it stays in there. If I did not have this vertical line, this would bleed over into this part. And if I didn't have this horizontal line, it would bleed under. So that's why you need these two conditions to make it trapped in that particular region. All right, so let's see. Here in question 9. Again, I've got x equals 0, y equals 0. So I've got the vertical line, horizontal line. They're both solid. Just that gives me that it lives here in quadrant 1. So now I need to figure out what does this line look like. Well, first off, it's going to be dotted. If I solve, I get y is 21 over 33. All right, so it is a line through the origin. That's 1 point. All right, let's see. I need another point. That's an ugly looking number, so I'm going to pick something that I can fit on the graph and will cancel. So I'm going to pick 11 because I know 11 will go into 33. So 11 into 33 goes 3 times, and 21 over 3 is 7. So that gives me this dotted line. And so now I'm going to pick a test point. I need to pick something that lives in there. Let's see what looks like it lives in there. Seems to be 2, 4 seems to be in there. Let's see if 2, 4 works. 2, 4. Let's see, 21 times 2 minus 3 33 times the y, which is 4. And is this less than 0? Well, 21 times 2 is 42 minus 4 times 33. So 4 times 3 is 12. Carry the 1. 132. Now, if I take 42 minus 132, is that less than 0? Yes. Therefore, all this stuff on the inside actually works. So let's go back to my math lab again and look a little bit more. All right, what if we had this case where x less than or equal to 4? All right, so I get out my graph. Let's see, I need to graph the vertical line x equals 4, and it is solid. Okay. 4. All right, crosses at 4, stays vertical. So there's my vertical line. I need to figure out which side works. So let's see. If I pick the origin, 0 is less than or equal to 4. So I'm going to put it on that side. Now, if I didn't like that, I could delete it. Okay, get rid of it. See? Back to my line. What if I picked this side? Oh, that was wrong. All right, so delete it. Try again. All right, so here's my line. And there. So if you have a problem, you can just clear the whole thing or delete the last object that you did. And we'll check it. Yes, it likes that. All right, let's go to one of these where we actually have a couple of things to do. Let's pick one with easier numbers. All right, so here I've got x greater than or equal to 0, y greater than or equal to 0, and this line over here. All right, so let's see. X equals 0 is the vertical line. Got that. Come on. All right. Now I need another one, the horizontal line. Now it doesn't matter which point I pick, just something to keep it there. All right. So got it. So there is that. Let's see. Now my other part is going to be dotted. So I need to pick the dotted part. It goes through the origin. Now I need one more point. Let's see, what's something easy? Let's see. So that's going to give me y is 21 over 7. 21 over 27, so that's going to give me, I need something that will go in nicely. Let's see. If x, let's see. Oh, I can't think of anything right now particularly, but let's say that that is what we need. And so now if I filled in my filling tool, it would fill in what we would need. Alright, so you do need to graph the vertical and the horizontal and your line, and then pick the particular region that it would be in. And again, if you want to start over, we would just say clear, and it would clear your graph and you could start again. Alright, that concludes section 5.1.